Okay, today we're going to hop back into chapter 4, section 5, and do U-substitution, but this time we're going to do U-substitution using the fundamental theory of calculus part 2 on definite integrals. Remember, definite integrals are integrals that have limits of integration. So let's review U-sub here for a minute. We'll do a couple U-sub indefinite integral problems. So here's a good candidate for U-sub. First thing, I'm going to rewrite it as the integral of 4x cubed times x to the fourth minus 7 to the 3/2 power. Remember, I set u equal to what was x to the fourth minus 7. That would make du equal to 4x cubed. So here I have one of the u-subs that is set up perfectly for me because I now do the substitution and I get u to the 3/2 and the 4x cubed and the dx that I didn't write. The 4x cubed and the dx make up du. So if that's little f of x, then big f of x would be 2/5 times u to the 5/2 plus c, or 2/5 times x to the fourth minus 7 to the 5/2 plus c. Remember, not all u-sub problems are set up as perfectly. Here is a u-sub problem where we're missing a constant in the du. So I'll give you about 90 seconds to do u-substitution and find me the integral of x squared times the quantity 7x cubed minus 2 to the fourth power. Alright, so we can see that we're missing a 21 because the du is 21x squared. So in order to put a 21 inside the integrand, I need to put a 1/21 or 1 over 21 on the outside, so that way those two things cancel out. So I can rewrite this integral like this. Then I can do my u substitution. It's 1 over 21 times the integral of u to the fourth du, or 1 over 21 times 1 over 5 u to the fifth plus c, which you would probably find as 7x cubed minus 2 to the fifth power over 105 plus c. Alright, now before we move on to definite integrals, I want to go back and cover a type of u-substitution that we didn't discuss last time. It's only slightly more complicated, And this is still a U-substitution problem, right? I can clearly see that there's an in when I rewrite it like this. But something different happens when I try to do my U-substitution. Alright, I set U equal to what the in was. And then my du is 1/3 dx. And that's how I know it's this sort of different type of U-substitution where I say it's a U-substitution with an extra x. This is my u, but I don't have that x as a part of the du. So I'm trying to do U-substitution with this extra x in there. Alright? And what I do for that is I take my u equation and I solve it for x. So if I add the two and multiply by 3, x is equal to 3u plus 6, just doing a little bit of algebra. So what's underlined in blue is my u. What's underlined in red is equal to 3x plus 6. So all I'm missing is that 1/3. So I can rewrite this as 3 times the integral of 1/3 x 1/3 x minus 2 to the 1/2 dx. Now I do all of my substitution. So that's 3 times the integral. Now remember, this 1/3 here and this x here, dx here, become my du. This binomial becomes u to the 1/2, and that extra x that I have becomes 3u plus 6. So I can rewrite the whole thing as 3 times the integral of 3, I'm distributing now, u to the 3/2 plus 6 u to the 1/2. And I can integrate that pretty easy. This is 3 times 6/5 u to the 5/2 plus 4 u to the 3/2 plus c, or 3 times 6/5 1/3 x minus 2 to the 5/2 plus 4 1/3 x minus 2 to the 3/2 plus c. So I do this process when I find myself trying to do U-substitution and I have an extra x. Anytime I have an extra x, I'm going to solve my U-substitution for x and then substitute everything in. Here's another problem with an extra x. I want you to go ahead and attempt this U-substitution. I'll give you 2 or 3 minutes. I'll start you off. For this problem, we're going to make u equal to what the in was. That looks like it's going to be x plus 1. Alright, so if u is equal to x plus 1, then du is equal to dx. So I can see that I'm going to have that extra x right up here on top. So to solve for that, x is equal to u minus 1. So now I do my substitution. I'm not missing a constant because I need dx and I have a dx, so I can just substitute right in. This is equal to 3 times u minus 1 minus 2 over u cubed du, which is the same thing as 3u minus 5 over u cubed du. My final simplification to make it easier to integrate is 3u to the negative 2 minus 5u to the negative third power du. I can integrate that pretty easily and make it negative 3u to the negative 1 plus 5 halves u to the negative 2 plus c, which would be rewritten negative 3 over x minus 1 plus 5 over 2 x minus 1 squared plus c. Alright, so yesterday we talked about the fundamental theory of calculus. Remember, fundamental theory of calculus part 2 was for definite integrals. Definite integrals have limits of integration, and we said that if I'm trying to integrate something from a to b, that's a little f of x dx, that's equal to big F of b minus big F of a, where big F was the antiderivative. So to evaluate a definite integral, all I have to do is find the antiderivative and plug in the top limit of integration and subtract the value when I plug in the bottom limit of integration. So here we have a definite integral, and it certainly looks like a candidate for u sub. And the key with definite integrals is to change the variables of integration, change those limits of integration. Right now they are in the variable x. When I make the u substitution, I need to make them in the variable u. So the beginning works just like u substitution. I set u equal to what the in was, x squared plus 9. I set du equal to the derivative of that would be 2x dx. So far nothing has changed. What am I missing? I've got an x and a dx, so I'm missing the 2. So I would say 1/2 times the integral 0 to 4 times 2x x squared plus 9 to the 1/2 power dx. Here's where the change comes. When I do my u substitution, this is 1/2 times the integral. This is u to the 1/2 du. But now I have an integral that is in terms of u. In order to evaluate that, I have to have limits of integration that are with respect to u. So my lower limit of integration was 0, but that was an x. When it's a u, I need to figure out what u is when x is equal to 0. I do that by plugging it right into my u equals. U equals x squared minus 9. So if x is 0, my lower limit is now 9. My upper limit was 4. What is the new upper limit in terms of u? Well, when x is 4, u is equal to 4 squared plus 9, or 25. So I find my new u limits by changing the variable and figuring out what that variable is with respect to u. Now I just do my u substitute or my integration. So this is going to be equal to 1/2 times big F of 25 minus big F of 9. What's big F? Big F is the antiderivative of u to the 1/2, which is equal to 2/3 u to the 3/2. I go ahead and plug that in. That means that my definite integral is evaluated at 1/2 times 2/3 times the square root of 25 cubed minus 2/3 times the square root of 9 cubed. I could simplify that pretty easily. That's 1/3 times 125 minus 1/3 times 27. So I get 98/3. I did that by simply distributing the 1/2 and taking the square root of 25 and then cubing it to get 125 and square root of 9, which is 3, and then cubing it to get 27. I'll give you about 2 minutes to try this definite U-substitution. Alright, so I set u equal to x squared, got 2x dx for du. So on this first line, I added in the 2 and had to have the 1/2 out in front. On the second line, I did my u substitution and I changed my limits to 3 to 6. I applied the fundamental theory of calculus, big F of b minus big F of a here. I found the antiderivative of u cubed, which is 1/4 u to the 4th. And I know these numbers got a little bit big, but when you're taking something to the 4th power, it gets pretty complicated, pretty big. And I got the final answer of 1215/8. Here's our last problem for today. It combines the two things that we learned. It is a definite U-substitution problem, and it also has an extra x. So I'll give you about 2 or 3 minutes to complete this problem. All right, we'll go through this one together. So u is equal to x plus 1, so du is just equal to dx. So it's set up well except for that extra x out in front. X is equal to u minus 1. So I can just go straight up and do my substitution. This is now u minus 1 times u cubed du, but I have new limits now. My new limits are now 1 and 2. I distribute that x cubed and it turns into the integral from 1 to 2 of u to the 4th minus u cubed du. So that's going to be equal to big F of 2 minus big F of 1. What's big F? Big F of u is going to be equal to 1/5 u to the 5th minus 1/4 u to the 4th. Plug everything in. I get the integral evaluated as 32/5 minus 4 minus 1/5 minus 1/4. Here is a few homework problems for tonight. The answers and the work will be on Edmodo.